This is our Srinivas Reddy School Assistant Math ZPHS Dharmajipet. Today I am going to discuss about basic concepts for the IIT Foundation classes, 9th class Mathematics, first chapter, that is real numbers. Now first question, what is a rational number and what condition must its denominator satisfy? A rational number is a number that can be written in the form of p by q, where p, q are the integers and the denominator q not equal to 0. The condition q not equal to 0 is essential because division by 0 is undefined. Already we know here something by 0 is undefined. A number that can be written in the form of p by q. A number that can be written in the form of p by q, where p, q are the integers. That means, suppose 2 by 3. This is in the form of p by q. Here both p, q are the integers. P means 2, q means 3. 2 by 3 is a rational number. And q not equal to 0, conditions is satisfied here. Therefore, 2 by 3 is a rational. Suppose, for example, 0.5. Now removing the point, this is 0.5 can be written as point by 10. This is in the form of p by q, where p, q are the integers, q not equal to 0. These two conditions are satisfied here. Therefore, 0.5 is a rational number. Here 2 by 3 is a rational number, 0.5 is a rational number. Next, 0.3 bar. This can be expressed as a p by q form. The exact value of 0.3 whole bar is equals to 1 by 3. Here 1 by 3 is a rational number. That means 0.3 bar is a rational number. That means all the numbers can be are in the form of p by q or can be expressed in the form of p by q. Can be expressed. Expressed means 0.5 terminating decimal. Now this can be expressed in the form of p by q. That means 0.5 is equal to 5 by 10. 5 by 10. 0.3 bar. This is a non-terminating recurring decimal. This is also can be expressed in the form of p by q. That means 0.3 bar is equal to what we know here, 1 by 3. So number which are in the form of p by q or which can be expressed in the form of p by q. These type of numbers are called rational numbers. What are the key points here? In that p by q, p, q are the integers. Both integers. First condition, this one. Now second one, q not equal to 0, denominator never be 0. When a fraction can satisfy these two conditions, then that is a rational number. Now second question. Why is every integer also rational number? Integers are denoted by capital I. Minus infinity and so on. Minus 3, minus 2, 1, 0, 1, 2, 3 and so on, plus infinity. Here every integer also rational number. This is the question here. Why? Any integer n can be written in the form of p by q. That means n can be written as n by 1. Since n and 1 are both integers and denominator is not 0, it satisfies the definition of real numbers. Therefore, every integer can be expressed in the form of p by q. For example, minus 3 is a integer. Here this can be written in the form of minus 3 by 1. Here take by denominator 1. So minus 3 is equal to minus 3 by 1. And minus 3 can be written in the form of minus 3 by 1, that is in the form of p by q. Suppose for another example 2. 2 is an integer. Here 2 can be written as 2 by 1. This is in the form of p by q. Both p comma q are the integer, q not equal to 0. These two conditions are satisfied here. Therefore, minus 3 is a integer, that is a rational number. 2 is a integer, that is a rational number. Similarly, minus 5 is a integer, that is a rational number, because that can be written in the form of 5 by 1. Therefore, all the integers can be expressed in the form of p by q. Therefore, all the integers are called rational numbers because they can be expressed in the form of p by q. Therefore, every integer also rational number. Every integer also rational number. Now, next question. Is 0 a rational number? Explain. Is 0 is a rational number? Explain. Yes, it is a rational number because 0 can be written in the form of 0 by 1. That is in the form of p by q. Here p is equal to 0, q is equal to 1. Both p comma q are the integers, q not equal to 0. All the conditions of rational numbers are satisfied here. Therefore, 0 is a rational number because that can be expressed in the form of p by q. Okay. Now next question. What is the fundamental differences between rational number and an irrational number? Rational number means that can be expressed in the form of p by q. Irrational number means that cannot be expressed in the form of p by q. Rational, irrational. A rational number can be expressed in the form precisely as a fraction of p by q up to integers, q not equal to 0. Its decimal form is either terminating or non-terminating repeating. An irrational number cannot be expressed in fraction of 2 integers and its decimal form is non-terminating, non-repeating. So, every rational number can be expressed in the form of p by q. That means all the numbers are in the form of p by q here. Here, not in the form of p by q and p by q form lo undavu. So, right. Next, the decimal expansion of rational number are terminating and non-terminating recurring decimals. Here, for the irrational number, the decimal expansion of irrationals, non-terminating, non-recurring decimals. Here, non-terminating, non-recurring. Here, terminating, non-terminating, recurring decimal. Major these two differences between rational and irrational. Every rational number can be expressed in the form of p by q. Every rational, the decimal expansion of every rational number may be terminating or non-terminating recurring. For irrational number, every irrational number cannot be expressed in the form of p by q. The decimal expansion of every irrational is non-terminating, non-recurring. Non-terminating, non-recurring. For example, 0.1234507 and so on. This is a non-terminating, non-recurring. This is a irrational. Suppose 0.5 is a terminating decimal. This can be expressed in the form of p by q. Therefore, this is a rational number. This is a terminating. 0.3 bar. This is a non-terminating, non-recurring, non-terminating repeating decimal. This can be expressed in the form of p by q. So this is equal to 1 by 3 answer. This is in the form of p by q. Right? So major differences in between rational and irrational. Every rational number can be expressed in the form of p by q. Rational number, the decimal expansion of rational numbers are terminating, non-terminating, repeating decimals. And every irrational number cannot be expressed in the form of p by q. The decimal expansion of irrationals is non-terminating, non-repeating decimal. Now next question. Define real numbers. The collection of all rational numbers and all irrational numbers combined forms the set of real numbers. Every real number can be uniquely represented as a point on the number line. Right. The collection of rational numbers and irrational numbers are called real numbers. So real numbers are denoted by capital R. Capital R is equals to rational, the collection of rational, so rational number, and irrationals. Here this is called real numbers. So real numbers lo rationals, irrationals rendu untayi. P by Q forms non-terminating, non-repeating decimals. For example, 1 by 2, 0.3, root 3, root 2, root 5 and so on. All these are rational numbers. Rational number is nothing but the combination of real and irrational. The rational number is nothing but the combination of rational and irrational. Okay. Next one. How can you determine if a number is irrational just by looking at its decimal expansion? Just by looking at its decimal expansion. Right. Decimal expansion చూసి అది irrational అని how can we determine? Here already we know here all the non-terminating, non-repeating decimals can be expressed in the form of P by Q. They are rational. But all the non-terminating, non-repeating or non-recurring decimals cannot be expressed in the form of P by Q. These are irrationals. For example, 0.34023 and so on. This is a non-terminating, non-repeating decimal. So this is a irrational. If the decimal expansion continues infinitely without terminating and without establishing repeating blocks, that means that is a non-terminating, non-repeating decimal. The number is irrational. Therefore, every non-terminating, non-repeating decimal is a irrational. The decimal expansion of non-terminating, non-repeating decimal is a rational. Okay. Next one. What type of decimal expansion does a rational number have? Already we know here the decimal expansion of rational numbers. Terminating decimal, first one terminating. Second one non-terminating, repeating decimal. Non-terminating, repeating or recurring. These two can be expressed in the form of P by Q. Therefore, all the terminating decimals, all the non-terminating, recurring decimals are rational. So, a rational number always has a decimal expansion, either terminates or is non-terminating but recurring, is a rational number. For example, 0.25 is a terminating decimal. This can be expressed in the form of P by Q. Therefore, this is a rational. Next, 0.3333. This is 0.3 bar. Therefore, 0.3 bar is a non-terminating, repeating decimal. This can be expressed in the form of P by Q. Here we know that 0.3 bar is equal to 1 by 3. This is in the form of P by Q. Okay. So, all the terminating decimals, all the non-terminating, repeating decimals are also rational numbers. Next question. If n is a natural number, under what condition is root n an irrational number? For example, root 2. For example, root 2. 2 is a natural number. Root 2 is irrational. Root 3 is irrational. root 4 is rational. Root 5 is irrational. Root 6 is irrational. Root 7 is irrational. Root 8 is irrational. Root 9 is rational. So root 4, root 4, root 9 and also root 1, root 25, root 16, root 36, all these are rational numbers. That means root 4, here 4 is a perfect square. Root 9 is a rational number, 9 is a perfect square. Root 1 is a rational number, 1 is a perfect square. Root 25 is a rational number, 25 is a perfect square. Root 16 is a rational number, 16 is a perfect square. Root 36 is a rational number, 36 is a perfect square. That means if n is a rational number, then n must be perfect square. If root n is a rational number, then n must be perfect square. If root n is a irrational, then n is not a perfect square. So here what is the condition we have here? If root n is a irrational, n is not a perfect square. Okay. Next one is the famous mathematical constant pi rational or irrational, and why do we often use 22/7? Right. Pi is a irrational number because its exact decimal expansion is non-terminating, non-recurring. The fraction 22/6 is morely a close rational approximation used to simplify practical geometrical calculations. It is not the exact value of pi. The exact value of pi is 3.1415926.535 and so on. This is non-terminating, non-recurring decimal. The exact value of pi is equal to this one. This is non-terminating, non-recurring decimal. Here we know that every non-terminating, non-recurring decimals cannot be expressed in the form of p by q. Therefore, pi is a irrational number. Here 22/7 is a approximate value of pi, that is not an accurate value. The accurate value of pi is equal to 3.1415926.535 and so on. Non-terminating, non-recurring. So accurate value of pi is this one. Here 22/7 is a approximate value, that is not accurate. Therefore pi is a irrational, because the accurate value of pi, that is a decimal expansion, that one is non-terminating, non-recurring decimal. Therefore, pi is a irrational. Next one. Can a number be both rational and irrational at the same time? No. The set of rational and irrational numbers are completely disjoint. Disjoint means different. A rational number, a real number is either rational or irrational, but never both, because a number cannot simultaneously be expressible and inexpressible as a ratio of two integers. So, the rational numbers are completely differ by irrational numbers. So, they are disjoint sets. The set of rational numbers and the set of irrational numbers, both these two sets are disjoints. That means they having no common numbers. So, the set of rational numbers, the set of irrational numbers are not same. Okay. Now next one. What do the mathematical symbols capital N, capital W, capital Z and capital Q represent? Capital N represent natural numbers. Here we know that, already we know here, all the counting numbers are natural numbers. All the counting numbers are natural numbers. They are denoted by capital N. So they are natural numbers. Equal to, natural numbers are started from 1. So 1, 2, 3, 4 and so on. This is natural numbers. Now second one, whole numbers. All the natural numbers are included with 0 is called whole numbers. So natural number ki 0 అని యాడ్ చేస్తే whole numbers ఫామ్ అవుతున్నాయి. Whole numbers are denoted by capital W. Similarly, integers are denoted by capital I or capital Z. Next, already we know here, rational numbers are denoted by capital Q. The numbers are in the form of P by Q. Okay. Natural numbers are denoted by capital N. Whole numbers are denoted by capital W. Integers are denoted by capital Z. And rational numbers are denoted by capital Q. Okay. Next one. Is every whole number a natural number? Every whole number a natural number. Here we know that natural numbers are started from 1. So n is equal to set of 1, 2, 3, and so on. All the natural numbers included with 0 is called whole numbers. So whole numbers are denoted by capital W. W is equal to set of natural numbers ki 0 add chestam. 0, 1, 2, 3 and so on. This is whole numbers. So what is the question here? Is every whole number a natural number? No, because 0 is a whole number, but 0 is not a natural number. Every natural number is a whole number, but the whole number 0 is not a natural number. సో హోల్ నెంబర్స్లో జీరో ఉంటుంది, న్యాచురల్ నెంబర్స్లో జీరో ఉండదు. బికాస్ therefore every whole number need not be a natural number, but every natural number be a whole number. Okay. Now next one, 63. How many rational numbers exist between any two given distinct rational numbers? There are infinitely many rational numbers between any two distinct rational numbers. This property is known as the density property of rational numbers. According to the density property, the rational numbers in between any two rational numbers infinitely. We have here the number of rational numbers in between any two rational numbers are infinitely uncountable. Suppose for example 2, 3. They are rational numbers. In between these two, 2.1, 2.11, 2.12, 2.10, 2.001. All these are lies in between 2 and 3. So how many we have here? Uncountable, infinity. That means the number of rational numbers in between any two rationals are infinitely or uncountable. Okay. So the number of rational numbers in between any two rational numbers is equal to infinity. Next one. How many irrational numbers exist between two rational numbers? Right. There are infinitely many irrational numbers between any two distinct rational or irrational numbers. For example, 1, 2 rational numbers. In between these two, root 2, root 3, 1.0123 and so on. All these are irrationals, lies in between 1 and 2. A root 2 value 1.414 and so on. Root 3 value 1.732 and so on. All these are non-terminating, non-repeating decimals. How many we have here? Root 2, root 3, 1.01234, 1.23012 and dash dash, like this. So we have here infinity irrational numbers in between any two rational numbers. Infinitely number of irrational numbers in between any two irrational numbers or rational numbers. Okay. So there are infinitely many irrational numbers between any two distinct rational numbers or irrational numbers. That means the number of irrational numbers in between both rational and irrationals are infinity or infinity. Okay. next one. What is the significance of the real number line? What is the significance of the real number line? The real number line illustrates that there is a unique real number corresponding to every single point on the line. And conversely, every real number can be mapped to a unique point on the number line. So, represent every real number by unique point. Represent unique number by unique point. Okay. Compare numbers easily. Measure distance. Understand ordering of numbers. Right. Now, suppose now when we are representing the real numbers on the number line, suppose now represent 2 on the number line. Here something 0, 1, 2. Here this is known as, this point is called, or this point is represented as a 2 on the number line. And this point is known as 2 on the number line. Now root 2 is equal to 1.414 and so on. So now we can, when we are representing the root 2 on the number line, approximately that is lies in between 1 and 2. Right, suppose this point is, say this point is 1.414 and so on, non-terminating, non-repeating decimal. So this point shows root 2. Here this point shows 2. Here this point shows 1. This point shows 3. Okay, that means a real number represent every real number by unique point. And every real number can be represented uniquely. Okay. Every real number can be mapped to a unique point on the number line. Okay.